All right, hello everybody. So the first new video of the new year. And you can see what our first project is here. I need to get these off the bench. It's a pair of Carver model C-19 preamps. And we're trying a new video camera mount that I just got it's kind of like an articulating boom arm. I really like it, with the exception of it is kind of wobbly, so if I bump the camera it'll shake around a little bit. The other thing we're going to try to do is I'm running the microphone without the deranged tribble. It kind of gets in the way and everything. I know it helps a lot with removing sibilants and things like that. So I'm going to try this video without it. If the sound quality is still good and everything, then we'll go with it. If not, then I guess the tribble will be placed prominently back onto the microphone. So you'll have to let me know how it sounds. So what we have here, these Carver, again, I know nothing about these. This is my first experience with the C-19 preamps. Apparently they have a vacuum tube in them. Actually, there's 4 vacuum tubes in them. In addition to the vacuum tubes, this is supposed to be Carver's best preamp they ever released. Now, I don't know, like I said, I know nothing about it. The thing I do like about it is, other than the spectral tilt, I love all these words Carver uses, there's really no other different, it's just very basic controls, as you can see. Bass and treble, tape monitors, selector, volume, balance, very basic. Now, this bottom one supposedly works properly, although it has somebody cut off their extension cord and used it as a new power cord. We're going to replace that with a nice new power cord here that looks a little more appropriate. But I will tell you, this top one is actually the cleanest of the two, but it has a serious problem. Let's take a look at it. I'll flip it around and show you. So if you take a close look at the back of this top preamp, all of these, the actual metal, the outer part of the RCA phono jacks is missing from all these. And I think that's the main problem with this one. If we can find a way to replace these, this top preamp is actually just in beautiful condition inside and out. Here's where I need some help, guys. I did some pretty good searching to find these. I thought these would be really simple, common connectors to find. I've seen them used in many different manufacturers. I'm going to open this up and show you a close-up of them. And maybe you guys can let me know if you have a source that you know of where I can find these, because I really don't want to modify this. I want to keep this thing original. And I would really like to just find these connectors if I could. So let's look inside and I'll show them to you. So I think the reason that those little metal caps got torn off there is that a lot of these modern RCA phono jacks are just, the phono plugs themselves are just really ridiculous the way they're made. Like, I'll show you an example of some that I have, and they're these ones here, and you can see they're not real springy. They're very, very thick, solid metal, and they don't move at all. And when you push them on, they're so tight that I just think when you pull them off, it just ends up ripping those caps right off. And I've seen that happen. Actually, I had that happen to one of my MP3 players. One of those little, I forget who made it, but it was one of those little ones. Same thing happened to it. So I think you really have to be careful with that type of, those plastic RCA phono jacks that have the metal, caps on the outside of them for the shielding. So we almost have this thing out here. Don't you love videos where you watch people take screws out of covers. Some people do the fast forward thing. I could probably do that, but you know, I don't think I will. I think I'll make you sit here and listen to me talk. Okay. And we're in. So if you take a look over here, you can kind of see what I'm talking about. If my camera quits wobbling, stop it. Okay. So you can see down in here, these are very standard connectors. And there's 1, 2, 3 sets of doubles. So there's, you know, one top and bottom. That's one unit. Second unit, third unit. And then they screw in caddy corners. So you have one screw that comes in from the outside over here, and one here, and one here for this one, and one here and one here for this one. And then there's a single stack of 2 right over here. I don't know if you guys can look at that and see if possibly you know of any sources that still sell these. I have to believe that they're still out there. I mean, I've seen these in Harman Kardon units. I've seen them in some of the newer Pioneer and Sansui equipment, some of the later ones. You know, well, later meaning like 1980s, 1990s, and so forth. So these have to be available someplace. I just haven't had much luck in finding these exact ones. But I would really, as you can see how clean this is inside, everything's original. And really, and these ones have some Yugoslavia 6DJ8s, and there's 4 tubes in here. They're all 6DJ8 or 6922s. Supposedly these sound really, really good. I don't know. I've not tried it. But apparently that's really all we need to do with this one. Now, the one that is supposedly in the better of the two, that was brought as a working unit, when I took it apart, it was a little bit different. Okay, so this one apparently works perfectly. But when you get inside, there is this thick coating you can see of grease. It's like this greasy, like mixed with dust and dirt, gook coating the whole inside of this thing, to the point where you can even see up here, see how wet it is? This is just all, you can see it, just oil. It's everywhere. You can see that this thing's been hot, and somebody has repaired the power transistors and replaced these 2 capacitors here, and these 2 capacitors here were replaced. And this doesn't look factory either. I'm not sure what this is, but you can see where they cut the traces and kind of swapped them, is what it looks like. That might be factory, it might not, I don't know. But this amp has this preamp has actually been worked on. You can see it. And then here's they put hot snot all over it and replaced this 2-prong with a 3-prong cord. I don't know if that's good or bad. So, you know, the first thing we need to do is just do a general cleaning on this. One good thing about this preamp is these are actual Jan Phillips 6922s made in USA. Very good tubes. I haven't tested them yet, but I'm sure they'll test out perfectly. Those are really good tubes. So that's kind of where we're at right now. First thing we need to do is do a cleaning job, and let's break out some schematics for this and kind of see what makes this thing tick and see why it's supposedly such a good preamp. Alright, so we got this thing apart and we have the board cleaned off. Believe it or not, the bottom of the board was spotless. There was none of that gook at all on the board. It's just the top part, and again, I can tell from these pots, it looks like it's some kind of a deoxit type stuff that somebody sprayed on there or something, and it just kind of ran all over the board and then dried and turned into that waxy gunk. I also cleaned, I'm removing these voltage regulators for your plus and minus 12 volts, and there was a lot of scorch marks around them, and you could see just the one I started cleaning off. You can see how much of this stuff is coming off of there. The other thing was, when I got the heatsink off that has the voltage regulator, it looks, I'm pretty sure, yeah, there's no heatsink compound on this. And really, with these regulators, these linear voltage regulators get really warm. So even if you don't need a mica pad for insulation, you still want to put a little dab of heatsink compound to really thermally couple this to the heatsink better so it can carry the heat away. If not, this will still get very, very warm, and it can scorch the board, kind of like what you saw there. There have been some capacitors replaced, but not all of them. And I'm just going to kind of go through. I'm probably not going to replace every single cap in here, because actually, quite frankly, most of them are still really good. But the ones that are around the vacuum tubes, I may replace those just for precautionary measure. That's about it. And then we're going to just put it all together and test it and kind of see where we are. So we'll get that done, and then we'll be back. And of course, we're going to replace this cord with something too. Alright, we're in the process of putting the new power cord on, and I think I see why they had a bunch of this silicone glue stuff on there. And that's because this is just kind of bubblegum soldered on there, and you can see all the solder balls and all loose stuff laying around in here. Kind of see it. So we're going to clean that all up and get it all put in the right way. Okay, we got a nice new power cord put in. Put a new XY capacitor in there. Got the solder joints all cleaned up. Cord looks a lot nicer. It's kind of a retro looking cloth covered. So that should be a lot better. So let's flip this over and do some other tests. Okay, after cleaning all of the deoxide or whatever that waxy dried out gook was off of each tube, I had to be really careful because I didn't want to damage any of the markings at all on the tube. I noticed that each tube was marked. If you look, this is number 2. This is number 1. This is number 3. And this is number 4. Well, actually 3 and 4, yeah. There's 4. They put the number 4 on it. This is number 3. So obviously these tubes were matched when they were purchased. So we're going to make sure we put them back into the same sockets that we found them. Now we'll go over the schematics a little bit. But what's going on inside here essentially is 2 of the tubes are used strictly for the phono stage, and then 2 of the tubes are used for the line stage. So you actually have 2 sets of individual vacuum tubes for the phono and line. So let's get them back in. And by the way, I had this powered up for quite some time, and they run absolutely cool. They don't even get lukewarm anymore. Voltage is right on. The capacitors that were in here, the original schematic calls for 25 volts at 2200 microfarads, but I noticed that the voltage coming into here was just edging over 25 volts, so that was a little bit high. I didn't have any 35 volt caps, so I went with 50s. They'll be just fine. And then these 4 capacitors along here I replaced with high temperature capacitors, just in case these did get warm. Everything else looks good, so we're going to test this thing out and see how it works. Okay, so we have our signal generator connected, and we're just going to see what kind of output we get and if the volume and balance and everything works. I'm feeding a 2.5 volt RMS signal into the CD in jacks, and we're going to see what we get. So you can see right now all that jumpiness. So in spite of being totally hosed down with something, the pots are actually There's your balance, and you can see how bad and scratchy they are. And I do have the tone control right now bypassed, because we're not going to listen to that right now. We just want to see how it works with just the volume and balance. So let's clean those the right way and try it again. Okay, we're cleaning the pots right now, and one of the things that I see happen a lot when I get different things on the bench is that sometimes people try to clean the pots or the potentiometers in these, and it's highly recommended to use this product, this Deoxit D5. Now the D5, that number there, means that there is 5% of the deoxit chemical in this, and that chemical actually is designed to stay behind, and what it does is it kind of lubricates the surface areas, the contacts that you're spraying, and prevents them from corroding, which is a good thing. The problem is too much of this is not a good thing, and if you just spray it crazily all over, it will get all over this, and it will soak down into the circuit board. It will get on top of the surface, and then when it cures, it gets kind of a waxy sort of substance. It's very hard to clean off. So in order to clean this properly, and you could see even with how much of this was sprayed, this whole board was covered on the top, and even the bottom, or around the edge, like all this was wet with the stuff. You saw that the pots were still noisy. It didn't clean it because it wasn't cleaned properly. So what I'm going to do is we're going to go over how to deal with this. So when you see something like that, the first product that I like to use is for cleaning these, and that's all we want to do is clean them first. And this is a product, there's a lot of different companies that make this. I like the CRC. It's locally purchased at most hardware stores and so forth. The important thing is it's a quick drying formula, so it dries right away as soon as it hits. It doesn't leave any residue. In other words, there is no other thing other than the evaporating cleaning formula, and it is plastic safe, so it won't damage any of the plastics, which is very important because a lot of the components in these do contain plastics. So what we're going to do is we're going to use this to actually wash all that sticky gook, whatever it is, out of the potentiometer, and then we can properly just apply a tiny bit of this to take care of anything else. So first thing we want to do is we don't want stuff to get all over our board. So I just take a paper towel and I just kind of put it around here whenever you could do this. And on this particular pot, it is pretty much sealed all around other than this little notch on the top. Now the other thing I did was you just take your heat gun, or you could take a lighter or whatever. Make sure you stay away from the aerosol can when you do it. And you can heat this little hose up and just put a bend on it. It makes it a lot easier to get in here and work on this. So I'm just going to put this in here. I'm just going to shoot some of that around. And I don't really care. It will soak into here, and any place else that splashes, it'll just kind of go away on its own. So as it evaporates. And then we're going to work this until it's clean. And all we're doing is washing out all that gook that's inside there, that gunk. Okay? And then once we do that, then we can go in with a product like this and just very, very lightly put just a little shot of it like that. That's it. No more. It's a tiny little bit. Clean any overspray out. You don't want it getting all over everything else. And then just work it in there. That's all there is to it. There's no need. First of all, this stuff is really expensive, and I could probably buy 5 or 6 cans of this for the price of 1 can of this. So that's the other reason that use this for cleaning, and then use this to just leave a little permanent coating on there. So that's how I do it. And again, I don't know how everybody else does it. This has worked for me for a very long time, And that's kind of how I do it, but just thought I'd share that with you. Okay, so another strange thing that I noticed when I was down here cleaning this was that this does not look factory, obviously. You can see where the tracks have been cut on these pins A, B, C, and D, and they have been kind of swapped around. So I did a little bit of checking, and the first thing I looked at was, let's move the camera up a little bit. I pulled the bottom off of the other one that I have, and let me get it in the same orientation. And if you look there, there is no jumpers on this. Would be right in this area here. So again, this is some kind of a mod or something that somebody did. Investigating a little further, these two purple wires or areas that I highlighted, these areas here are what seem to have been swapped, and that is your left and right channel. And if you notice, they go right into your volume controls. So for some reason, and I'm not sure why, it looks like, I'm not 100% sure, these schematics are lousy. They're really hard to read. They're blurry. And every copy that I've gotten from every source I've gotten have all looked like that. But from the best that I can see, it looks as if they swapped the left and right channels in here. Now, why somebody would do a bodge job like this and do that is totally beyond me, because why couldn't you just take the RCA plugs on the back and swap them around? I don't know. But anyway, for some reason, this has been swapped around. And again, I could be wrong. This could be doing something besides that. But from what I could see in the schematic and what it looks like is that they swapped the left and right channels around at the volume pot. Now looking on this side here, over here is where they did the swap out, and then that goes up here to U21, or I'm sorry, the swap out was down here, and then it goes up to this U21 on this riser board. And again, I just don't know why they're swapping that around, but definitely some work has been done on this preamp. And the funny thing is, this came on the bench just to kind of be cleaned up a little bit. It was on a system, the person who had purchased it was actually using it and said it was working perfectly. So the mystery thickens. I don't know. So anyway, that's I'm going to leave that as is, because obviously it was put that way for a reason, and the owner of it is using it that way and is happy with it. So I'm going to leave sleeping dogs lie, I guess. Okay, we're back on the oscilloscope, and we have our signal generator connected back in. And let's turn this up and see what we get now. And I have the sensitivity set way up. I'm down at 200 millivolts per division. So we're just going to look at the very beginning of the pot to make sure that it's nice and quiet. And you can see now, after cleaning it the proper way, there's absolutely no noise whatsoever. And you can also see that with the same drive signal going in, that the output is a little bit different, but again, that's because of the type of potentiometers. Those cheap little potentiometers aren't real accurate. They're close enough, but without a stepped attenuator, it's hard to get them to go up and track properly. But there's no noise. It looks good. So, all right, so we fixed that problem, and everything seems to be working. Okay, I really can't explain this, but channel 1 is your left, channel 2 is the right. Okay, so I know which one is left and right. And even with those jumpers in there, if I turn the pot to the left, the balance pot, you can see my right channel goes away. And if I turn the pot to the right, my left channel goes away. So it is wired properly, and it is not affecting the output. So I really, once again, don't have an understanding of why that little cross jumper was put in there like that. So that's going to bother me now. Any of you folks that's better on the Carver gear can explain that to me. I'd be thrilled. Send me an email, or put a message down there, a comment. That would be great to know. But everything seems to be working. So let's just test all this out. I'm going to just go through and check all the inputs, make sure everything's working. And then maybe we'll just connect it up to the bench amplifier and just kind of see how it sounds. Alright, all the inputs are working really well. But I think I spoke too soon when I talked about these running very cool now. I did put two new voltage regulators in there because the ones that were in there were the correct ones, but they were not from the same manufacturer and so forth. And there are different types of 78 and 79, 7812 and 7912s. There's some that are a little bit little heavier duty than others. So I put a good known set in, and these do run extraordinarily warm. I mean, to the point of hot. And one of the reasons for that is when I looked, first of all, you have 24 volts DC going into these, so you're dropping almost 50% of that voltage because you're going from 24 volts down to 12. The more voltage that these linear regulators have to drop, the more energy they have to dissipate, because it's all based upon your current and voltage combined. So the amount of wattage that this has to dissipate is quite a lot. Now these are rated for a maximum of 1.5 amps at 12 volts output. And these actually are creating the voltages for the vacuum tubes. And it's kind of strange because they're running the phono section, I believe, on the negative 12 volt supply, and they're running the line section on positive 12 volt supply. So each one of these feeds the filaments for two of the tubes. The vacuum tubes, these 6922s, are rated at 6 volts filaments, 6.3 volts each, plus or minus 0.7 volts, it says, or plus or minus 0.6 volts you can have. And they're put in series. So the two in the phono section are in series, so they would be 12 volts total in series string, and the two other ones in the line stage would also be 12 volts with the two 6 volt filaments in series, and they draw approximately 300 milliamps. So you're already dissipating 300 milliamps, or you're drawing 300 milliamps through your 12 volt supply just from the tubes. But the plus and minus 12 do more than that. They actually feed all of the logic chips. So all of the chips that are in there, all of the op amps that are used, all of the voltages for the amp or for this preamp go through those little 12 volt regulators, with the exception of the high voltage supply, which they're just using a little voltage doubler circuit. And if you look down here, there's a 180 ohm resistor, and that 180 ohm resistor goes through a voltage doubler circuit and comes out at about 40 or 50 volts or so. So really the plates of these tubes are actually very low voltage on them. I don't know. We'll see how what these tubes do. In the phono stage, I'm not so sure, of what they'll do, how they would change the sound, because you basically have one of these op amps at the input of the tube, and you have another one of the op amps at the output of the tube. So there's op amps all through the audio path. I don't really know how much sound will be affected by putting a vacuum tube in line with all that, but everything I hear about these is they sound really good, so there must be something to it. The other thing I noticed is I really like this circuit here. This is the one tube, and this is the one capacitor that you probably, that's not a film capacitor, it's an electrolytic. You probably want to put a really high quality cap in here, and I may do that before I button this thing up. But I really like the way they use the cathode here for your contour circuit and for your low frequency turnover circuit. They do it all down here. That's pretty neat how they're doing this. Some of the circuitry, just like all the other Carver gear I've worked on, it's kind of unique. There's some neat looking, circuitry in here. So I'm going to probably swap that out. These are just going to run really hot. I wish they didn't run so hot. They're actually discoloring the circuit board. Having that much heat this close, even though these are now 105 degree caps and these ones are 125 degree Celsius caps, they still are going to be, they're going to shorten their lifespan by having so much heat on these things. Like right now, I can't even hold my finger on them. They're so hot. They're just so warm right now. So yeah, it would be nice if I had less, if this was less than 24 volts. If this output would have only put maybe 14 or 16 volts into here, these wouldn't run nearly as hot. I don't really want to put a fan or anything in here because I don't want any noise or anything. So looks like it's going to be what it is. So that's about it. Let's put this thing back together and get it to its owner here, huh? Okay, I have my distortion meter connected up, and it's connected directly to my signal generator. So the distortion that you're seeing there, the 0.00 whatever, bouncing around 3% or so, is basically the limitation of my test equipment between the meter, my signal generator, the connections, the cables, whatever. That's the best possible scenario that we can get from our test equipment. So looking at that, we're going to take this now and we're going to connect according to what they're asking for here on this preamp. And as you can see, with 100 millivolts at 1 kilohertz, sorry about the bouncy camera with my new stand, we should see when we drive the volume below 3 volts RMS output, we should get 0.07% total harmonic distortion or less. So again, there's many other ways to test this, and there's, you can get into all kinds of fancy things, but this should at least give us an idea of what we're looking at. So I'm going to connect everything up and we're going to check and see what we get. Alrighty, so we have everything connected up, and as you can see, where you have about 3 volts RMS coming out of the preamp, that's what we're looking at. And if we go up to our distortion meter, we're doing way good. 0.004% THD. Now let me show you something funny. I am set in bypass right now, so what that means is all the tone is flat. There's no influence of the tone control. I have all the tone controls set flat, and watch what happens when I turn the tone amplifier on. Instant jump in distortion. Now, of course, it's still 0.16% total harmonic distortion, which is going to be very low. You're probably not going to hear that. But you can see the influence of adding all that extra circuitry in there and looping all this, the audio path through that tone section, the tone control section. If I turn it back off, it goes right down to nothing again. So it just shows you how much distortion and noise that you can actually add to your signal path just by using a tone control section. That's why you see a lot of these really super high-end preamps and so forth, and amplifiers and sound systems. They don't have any tone control whatsoever. They're very minimal in the audio path. You have a volume control, which is usually a stepped attenuator, and it goes straight into the amplifier. And this is why. Again, turning the tone on. And remember, I have all the bass and treble controls set totally flat. In other words, they should not be influencing the sound at all because they're set flat right now. But again, now you don't really see it on the amplifier itself or on the waveform because it's too small of a distortion to actually see on the oscilloscope, but it does show it on that. So I just thought that'd be something interesting. So really, this wasn't a super exciting video. There wasn't any big problems this time, thank goodness. And so this one worked out pretty good. So this is ready to go back to the customer, and I'm sure he's going to get a lot of years of enjoyment out of it. And I got a chance to work on one of these and to kind of test it out. And all in all, I think it's pretty good. Okay, we'll just do a quick sampling here of some sound. Hopefully I won't get flagged for that, but it's sounding really good. It's working really good, and we'll just back up a little bit here and take a look at how she turned out. Looks pretty good. So another project finished, and man, do I have a lot of things to do now coming up. So stay tuned to the channel. Quite a few really interesting pieces of equipment going to go on the bench this year. So thank you all for watching and for coming along. Thank you all for the donations and for the all the comments and good emails and so forth. I'm sitting on a whole pile of emails that I need to answer, so I promise you I'll try to get back to all of you as soon as I can. So again, peace, joy, happiness, and good health in all your lives, and I wish you all the best. Thank you for watching, and stay well. Talk to you soon. Bye-bye.